expressions with rational numbers. So we're going to develop our sign number sense. Today's goals: I can add, subtract, multiply, and divide rational numbers. I can evaluate expressions that involve rational numbers. So make sure you have today's date, your I can, page number, and you're ready to move on. All right, let's do a little true false here. So remember that if you have parentheses, you can leave out the multiplication symbol. You're still talking about a product, but like here, instead of putting the dot every time, if you've got things in parentheses, it's understood that when you've got two things beside each other in this manner, means to multiply. Okay, so you're always finding the product in those situations. All right, so let's do a little true false here. So decide if each of these is true or false. If I multiply this negative 38 and 76/100ths by 15 and 6/10ths, product's going to be negative. No, it's actually going to be positive, right? Two negatives multiplied together make a positive. What about here? 10,000 minus 99,999 is going to be less than 0. Yeah, it is, because that's going to make a negative number, making it less than 0. What about 3/4 times negative 4/3? Nope, you're going to get something it's going to be a negative 1 is what's going to happen, because you're going to have 12 over 12, and it's going to be negative, so 12/12 reduces down to negative 1, which is still not the same as 0. What about this last one? 30 times negative 80 minus 50 is the same as 50 minus 30 times negative 80. Well, these two parts are the same, right? It really kind of boils down to here. And no, it's not going to work, because here we're subtracting 50. Here, instead of subtracting the 50, we're subtracting the product that we get here, which is actually going to be adding that together, right? Because this was a negative number, and since we're subtracting a negative, it'd be like adding a positive. Whereas here, we're going to have a negative and then subtract a negative. So it's going to be, one's going to be positive, one's going to end up being very negative. All right, so we're going to look at some numbers here real quick. We're going to talk about like what the answer would be. So both of these expressions are equivalent, right? Because I can add a negative number or subtract a positive number, and I get the same thing. What do I get in either case? Yeah, this is going to be negative 17, right? What about here? Negative 4, or negative 1 times 4, and 1 divided by negative 1/4. Well, this is going to be doing the same as this here, except that that negative sign is with the 4 instead of the 1. But in either case, you're going to end up with negative 4. Okay. Do a couple more here. Let's skip down to here. What about 8 divided by negative 4, or 8 times negative 1/4? Again, dividing by a whole number or multiplying by the inverse fraction, going to give you the same thing. In either case, negative 2. What about 15 times 1/6, or negative 15 divided by negative 6? Yeah, both these are going to be positive, right? Because we have two negatives here, which make a positive, and we have two positive, which always gives us a positive. We get 15/6. 6 will go into that 15 twice. So that gives us down to what? 2 1/2. Yeah. Okay. All right. Let's jump ahead to some other ones here. Hang on. So when we think about these numbers and the expressions, remember that when you have a negative here, it's the same as adding a negative number, or if you have a subtraction and you have a negative number, that's the same as adding a positive number, right? So we could really rewrite this as negative 10 plus 7, right? Which is going to give us negative 3, because what this is saying is that you're going to take off negative 7 off of this. Well, if you take negative 7 off, you're counting backwards towards 0, and that's how you end up with the negative 3. So true or false? Oops. Subtracting a number is the same as adding the opposite. True, we just talked about that. Dividing a number is equivalent to multiplying by its reciprocal. Yes, it is. Remember, if we talked about if you have 4 times 1/2, that is the exact same as 4 divided by 2. Same thing either way. A number and its reciprocal have different signs. That's false. If I have 4 divided by negative 1/2, it's going to be the exact same as 4 times negative 2, or negative 2 over 1. Because remember, reciprocal is just taking the fraction, putting the numerator into the denominator and the denominator into the numerator. The sign carries through. All right, let's look at putting some of these into order from least to greatest. Which one of these is least? Yeah, negative 17, right? Because it is the one that's the furthest from 0, and it's the furthest left. What's next? Yeah, negative 4. It's closer to 0, but still to the left. Remember, you can always draw out a number line if you're having trouble remembering these. Oh, we got negative 3. We got negative 2 5/10. Negative 2. And in each case, we're getting just a little bit closer to 0, right? Now we don't have any more negatives. Now it's just how we always have done numbers, right? So that would make 2 next. I'm going to have to continue this down here. 2 5/10. And 3. And 4. And again, always remember that when we're talking about least to greatest and we have negatives, the larger the digits are with a negative, the least value it has compared to other numbers. Okay, which of these expressions do you think is going to end up having the largest value? Probably the a squared, if whether it's negative or a positive. If it's just a positive, it's probably going to be b cubed, isn't it? But if that's a negative, then it would end up having the smallest value. As far as closest to 0, it's probably going to be whatever the two numbers are subtracted here. But you know what? Really kind of hard to tell from just what we have at this point, isn't it? Yeah, because we don't know what digits we're plugging in, so it really could vary quite a bit. Let's try and do a few of them with some numbers. So b is negative 2, a is 10. So what is negative b? Yeah, that's going to be 2, right? Because we're just saying that we're putting opposite sign of what's there, so that's 2. What about b cubed? Well, negative 2 times negative 2 is 4. 4 times negative 2 is going to be negative 8. What about a times 1 over b? A is 10, and then times negative 1/2. Yeah, it's going to be negative 10 halves, which is the same as negative 5. What about a over b divided by a? Well, we can rewrite this one, can't we? It's 10 over negative 2 times, and we can flip this, so we have 1 over 10. We can actually cross cancel, and that gets us down to negative 1/2. What about a plus 1 over b? Yeah, so this is 10 plus negative 1/2, so we have to take a negative 1/2 off of 10, which gives us the whole 9 and 1/2. And what about b squared, 1 over b squared? So before we square it, we've got negative 1/2 squared, right? It's 1/4, isn't it? Because 1 squared, 1 times 1 is 1. Negative 2 times negative 2 is still 4. So we worked on some flexible thinking with all 4 operations across rational numbers. We talked about multiplicative and additive inverses and differences between those. So like multiplying by... All right, so we did a little bit of flexible thinking on all 4 operations and talked about how those multiplicative and additive inverses, in other words, adding a negative when you're subtracting a positive, or when you're subtracting a negative, it's the same as adding a positive, or with a multiplicative inverse, when you're talking about dividing by a number, it's the same as multiplying by its reciprocal. Reviewed those concepts today, all right? I think we hit everything in, so hey, time for practice. Thanks for watching.